All right, so today we're going to be looking at lesson 22.4. We're going to be solving right triangles. So they start off by telling us that we have a right triangle ABC and it has an acute angle A. And they tell us that we know the sine of angle A is square root of 3 over 2. So we want to draw a possible right triangle ABC. So first off, you're going to draw a right triangle. And then it told us angle A was an acute angle. So I'm going to put A here at the bottom, but you could put it up here where I'm putting C. It doesn't matter. You just got to make sure that it's one of your acute angles. And then B and C can be the other two. And it doesn't matter which one is B and which one is C. You have options there. So sine is opposite over hypotenuse. So what that means, square root of 3 is your opposite. So from angle A, this side is opposite. So this is the length square root of 3. Your 2 is your hypotenuse. So this length, CA, is 2. Then we want to find the length of BA. So I'm going to use Pythagorean theorem. A squared plus B squared equals C squared. So my A can be this side length, which is the square root of 3. So square root of 3 squared. I'm going to leave B as this side BA. And then C is your hypotenuse. So C squared. So square root of 3 squared is 3 plus B squared. And then 2 squared is 4. So you have B squared equals, subtract 3 to get the 1. From there, we're going to take the square root. So that means the square root of 1 is just 1. So this bottom side length is a 1. So there is your right triangle. From there, they want us to figure out what the measure of angle A would be. Well, angle A, we're going to be using special right triangles. This is a 30, 60, 90 degree triangle that we looked at with activity 21. And comparing 1 and the square root of 3. Square root of 3 is 1.7. So we have 1 and 1.7. Which of those is bigger? Clearly the 1.7 is bigger. So when you're looking at your 30 degree and your 60 degree angle, the 60 degree goes with the 1.7. They are opposite of each other. So here is our square root of 3. The angle that is opposite it is the angle A. And so that is why the measure of angle A is 60 degrees. And you can confirm that using your trig that we're about to look at with the inverses. So what we were just looking at is that we were given the sine of an acute angle A. And then we were supposed to find the angle that had that same ratio. Basically, we were looking for the inverse sine function. And this is written like this. And so that's what I was saying. You could use your calculator. If you plug in sine inverse of the square root of 3 over 2, it will give you 60 degrees, which is what we found. And so, if you wanted to try that with your calculator, you absolutely could. So if we plug sine inverse of square root of 3 over 2 in our calculator, what we're going to do, you're going to hit the second button right here, and then the sine, and right above it in blue it says sine -1. Some of you were asking in the previous lesson, what does that mean? And that's what we're looking at today. So if you click second sine, it'll give you sine inverse, and then you can do square root of 3, close your parentheses, and then divide by 2. And it'll give you the 60 degrees. So that's how you could have done that with the calculator. So where did that come from? So let's look. This is when you're looking for an angle. So this sine inverse, sine -1, you can write the inverse sine of x, or the sine inverse. So the inverse sine of x, or sine inverse. These are your inverse trig functions. And so the way that the book defines them, if the sine of A equals x, then the sine inverse of x equals the measure of angle A. Basically, your A and your x switch places. They invert. And if you see invert, inverse, very closely related. So if I have the sine of angle A equal to x, these two are going to switch places. And so what I do is write A equals the sine inverse of x, so that my A comes down and my x comes down. You're not going to be dividing by sine or by cosine or by tangent. You're just switching your x and your A. So we are going to use our calculator to evaluate each of these to the nearest tenth. So let's look at our calculator. So the very first one is sine inverse of 1/2. So we're going to hit second, sine inverse, and then we're going to do 1 divided by 2. And if nothing is going after this, you do not have to close your parentheses. And you should get 30 degrees. For part B, coming over here to the right, you're going to hit second, cosine inverse. You don't have to do 1/2. You could do 0.5. So you can do a fraction or a decimal here, and it gives you 60 degrees. Looking at C, second tangent inverse of 1/2 is 26.6. And they said round to the nearest tenth, so 26.6. For part D, sine inverse of 3/4 should give you 48.6. All you're doing is plugging these into your calculator. Second cosine, 3/4. So cosine inverse of 3/4 is 41.4. And then part E, you should get 36.9. So what this means, this is a triangle where the ratio of my opposite to hypotenuse is in a ratio of 1/2. 1/2 is what my opposite to hypotenuse reduces to be. And so when I did that, I got a 30-degree angle. And that's going to be the case for every triangle that has a 30-degree angle. The opposite to hypotenuse is going to reduce to a 1/2. So you're given your side lengths here on these, and you're looking for your angle. And so let's go back to the book. It says at the bottom here, using your known measures to find your unknown parts is known as solving a right triangle. So whenever they give you a right triangle and they tell you to find your angles or your side lengths, what they're asking you to do is solve the right triangle. So let's look on the next page. Trisha designs the logo shown for one of her clients. She needs to know all the missing dimensions and angle measures of the logo. So we're going to model with mathematics. Use an inverse trig function to find the measure of angle Q. So first off, just like what we were doing in the previous lesson, you want to pick an angle. So they told you to find Q. So we're going to pick angle Q. So we're going to use angle Q. Then we are going to label our side lengths. So the hypotenuse is this QR. Adjacent to Q is the 33. And then opposite angle Q is the 65. So I have my adjacent and my opposite that have numbers. The hypotenuse isn't going to be helpful right now because there's nothing on the hypotenuse. So what uses adjacent and opposite? Tangent uses opposite over adjacent. So I am going to do the tangent of angle Q. And the tangent of Q is opposite, which we said was 65, over adjacent, which we said was 33. So then, to find angle Q, the tangent inverse of 65 over 33. And so, tangent inverse of 65 over 33, if you use your calculator, you should get 63, and they don't tell you what to round to, so I'm just going to go to one decimal place. 63.1 degrees. So that would be for number 3, finding Q. Once you find Q, there are 2 different ways to find measure R. And you may actually have more than just 2, but there are 2 obvious ways. So one of them is, we know that the three angles in a triangle equal 180, or we know that angle Q and angle R equal 90. They are complementary. So I know that the measure of angle R is going to be 90 minus the measure of angle Q. Before I even found Q, I knew that, because they have to be complementary, because I know I have a right angle. So that means that the measure of angle R is 26.9 degrees. So that's one way, but it said describe two different ways. So another way would be to go back and use trig. So I'm going to do this one in blue so that you can see. My hypotenuse is still the hypotenuse, but in relation to angle R, the 33 is now the opposite, not the adjacent. And the 65 is now the adjacent, not the opposite. So I again am using opposite and adjacent. So that's going to be tangent, but I'm looking with respect to angle R. So the tangent of angle R, opposite we said was 33, and adjacent is 65. So notice this fraction is very closely related to this fraction. They're reciprocals. And that's because we're looking at different angles. Up here we were looking at angle Q, but right now we're looking at angle R. So whenever I go to find angle R, tangent inverse of 33 over 65. Notice this fraction doesn't change. It is different than this one, but it doesn't change when you're dealing with going from tangent to tangent inverse. So when you use your calculator, tangent inverse of 33 over 65 gives you 26.92 if you rounded, which is basically what we found. So no matter what, you should still get 26.9. So up to you how you do it. Either way, you should get the same answer. So now looking at number 5, we want to find two different ways to find the length of the hypotenuse. And I want you to find the length using both methods. So one option is to use Pythagorean theorem. So I'm going to start with that one. A squared plus B squared equals C squared. So my A and my B are the 33 and the 65, because those are my legs. And then my hypotenuse is the C squared. So if you do 33 squared plus 65 squared, you get 5,314. Then you take the square root of that. And so the square root of 5,314, I get that C is 72.9 if I round to one decimal place. So that would be my length of my hypotenuse. So that's one option. Another option is to use trig. And so there are actually 4 different ways that you can use trig here. And I'm just going to do one of them. But any of the 4, you should still get the same thing. So I'm going to erase, because we've got a lot on our triangle right now. I'm going to use angle Q. So I know this is my opposite, this is my adjacent, and this is my hypotenuse. So you can either, if you're using Q, you can either use sine or cosine. Either one of those has the hypotenuse in it, which is what we're solving for. So I'm going to label hypotenuse as C, just so that I get the same variable as what I had earlier. You can use sine or cosine. If you use sine, sine is opposite over hypotenuse. So we said angle Q. So the sine of angle Q, which is 63.1, and then 65 over C for your hypotenuse. So then we evaluate. Sine of 63.1 is 0.892. And then you multiply by C. And then you're going to divide by the 0.892. So 65 divided by 0.892 is 72.86, which rounds to 72.9. So that's one of the methods. You could have used cosine of 63.1, and then you would have had 33 over C. Or you could have used angle R and used the 26.9 and done either sine or cosine. So again, there are multiple ways that you could solve for the hypotenuse. And you get to pick which one you use. If you prefer using Pythagorean theorem, even on a trig quiz or test, that's fine. I'm okay with you doing either method as long as you're working through correctly. You're typically going to have to do some amount of trig before you can go back to Pythagorean theorem anyway. So now let's look at number 6. What is the minimal amount of information needed to solve a right triangle? So what you need to be able to find the other missing parts is what this is asking. At a minimum, you need either 2 side lengths or 1 side length and 1 of the acute angles. We already know that we have a right triangle. So you have to have either 2 of your side lengths or a side length and acute angle. Why would 2 acute angles not be enough information? Well, I don't know if I have a little bitty triangle that is a 30, 60, 90 degree triangle, or if I have a triangle this big that's a 30, 60, 90 degree triangle. You need to know at least 1 side length to know the ratios for the other ones. Looking at number 7, what's the difference between the expression sine of 15 and sine inverse of 0.2558? So if you use your calculator, sine of 15 is 0.2588, and sine inverse of 0.2558, if you round to a whole number, is 15 degrees. So one of them gives you a decimal, 0.2588. One of them gives you an angle degree, 15 degrees. How are they related? Do you see that those answers showed up there and there? These are called inverses. The inverse of this one gets you back over here, going back and forth between them. So that's how those are related. So let's look now at number 8. Angle X is an acute angle in a right triangle. What measure of X makes each statement true? Round each angle measure to the nearest tenth. So what you're basically doing here is using your calculator, and you're going to do for part A. If it says cosine of X equals 0.59, you're going to do cosine inverse of 0.59. And then you should get 53.8 degrees. So all you're doing is using your calculator, and you're doing second and then whichever trig function they give you. So for B, tangent of X equals 3.73, you're going to do tangent inverse of 3.73, and you should get, this one rounds to 75.0 degrees. The next one, sine inverse of 0.87, should give you 60.5 degrees. For a tangent inverse of 0.18, you should get 10.2 degrees. For part E, you should get 88.9 degrees. And then for part F, you should get 71.8 degrees. So again, all of those, you're just using a calculator. If you're getting domain error, what that probably means is you forgot to hit second before you did your sine, cosine, or tangent. You need to make sure that you hit second and then sine so that you have the little -1, the little inverse part of it. So now let's look at number 9. They give us the 27 on our hypotenuse and the 49 degrees. So the first thing that I can do is to find my other angle. So I know that angle A and angle B are complementary. So 90 minus 49 means that this angle is 41 degrees. Then I can use trig to find my 2 side lengths. So I'm going to label them X and Y. You can label them however you want. And I'm going to use the 49 degrees, but you could use the 41 degrees if you would rather. So 49 degrees, the sine of 49 degrees is opposite, which is X, over hypotenuse, which is 27. So this is like what we did in the previous lesson. You're going to evaluate the sine of 49, which is 0.755. And that's equal to X over 27. So then you're going to multiply by 27. I'm kind of running out of room here. didn't leave myself enough room. So 27 times 0.755, and you should get 20.4 for your x. Then for y, I'm going to use cosine. So the cosine of 49 is y over 27. So cosine of 49 is 0.656, and then you're going to multiply by 27. So 27 times 0.656 gives you 17.7 for y. So that would be your two side lengths there and your angle. So on all of these, you're going to have three parts that you are trying to find. Okay, for part B, it says, if you look in the direction, solve each right triangle if possible. Why is it not possible on this one? Do they give you a side length? No. Since we don't have a side length, it's not possible to actually find your three side lengths. We don't know the length of any of the sides to be able to set up our ratios. If you looked at sine, cosine, or tangent, for either 18 or 72, all of them, you would have your angle, but then you would have a variable here and here, and you would not be able to solve that. So that's why part B you can't do anything with. Looking at part C, so we could do Pythagorean theorem to find C, or to find ED, our side length, because that's our hypotenuse, or you can use trig. But if you're going to use trig, you have to find an angle before you can find your hypotenuse. So that's up to you how you want to do this. If you want to use Pythagorean theorem, 15 squared plus 9 squared equals c squared. And then 15 squared plus 9 squared is 306. And so the square root gives you 17.5. So if you wanted to do that for your side length, you absolutely could. Even though we're dealing with trig, you can still use Pythagorean theorem. To find one of the angles, you're going to need your 9 and 15, which, if we're looking at angle E, this is opposite and this is adjacent. So that's going to be tangent. So I'm going to come over here. Tangent of angle E, opposite over adjacent. Now, I know that 9 over 15 does reduce, but you don't have to reduce it. You can leave it just like that. E is going to be equal to tangent inverse of 9 over 15. And so if you plug that in, you should get that E is 31.0 degrees. And then I know that angle D and E are complementary. So if angle E is 31 degrees, that means angle D must be 59.0 degrees. So that'd be part C. For part D, if I know this angle is 68, 90 minus 68 tells me that this angle here is 22 degrees. And then I'll say D and E for these two side lengths. To find side length D, I'm going to use tangent of 20, or you could even use, you could use either one, but I'm going to do tangent of 22. And the reason, I wanted the D to be in my numerator so that I didn't have to multiply and then divide. So tangent of 22, opposite over adjacent. Tangent of 22 is 0.404. And then I'm going to multiply by 58. And that'll solve for D. So D would be 23.4. Then, to find E, you could either do Pythagorean theorem or you could use another trig ratio. Going with the 22 degrees, I could do cosine of 22 degrees, which is 58 over E. And so the cosine of 22 is 0.927. So you're going to multiply by E, because that's what's in your denominator, and then divide by 0.927. So 58 divided by 0.927 is 62.6 for that side. So those are the two sides on part D. So now let's look at number 10. Without using a calculator, how could we find the value of tangent inverse of 1? So I'm going to come down here, and I'm going to draw a little triangle. And this is my angle that I'm looking at. Tangent is opposite over adjacent. Another way to write this, tangent inverse of 1, I'm going to make up a variable, a, or we already have a as adjacent. I'll make up, I'll say g. So 1 is equal to the tangent of g. That is what this is saying. Tangent, we just said, was opposite over adjacent. So 1 is equal to our opposite over our adjacent. So what that means, our opposite and our adjacent are the same thing, because when you divide them, you get a 1. So what that means is that our legs are congruent. And so this must be a 45-degree angle, and this must be a 45-degree angle. And so that's how I can find the value of tangent inverse. I know it must be 45 degrees because my opposite over adjacent have to be the same thing. So now let's look at number 11. We have a rhombus ABCD, and they tell you AC is 8 and BD is 12. What are the measures of the sides and the angles of the rhombus? So I'm going to erase this. That's a terrible rhombus. It's a little bit better. So we know that all of these sides are the same because it's a rhombus. So A, B, C, D. They tell you A to C is 8 and B to D is 12. We know that the diagonals of a rhombus bisect each other. So if this whole thing is 8, this part is 4, and this part is 4. And if we know this whole thing is 12, this part is 6, and this part is 6. So you could use Pythagorean theorem to find your hypotenuse if you wanted, or you could use trig. I'm going to look at this one triangle. I'm going to make it a little bit bigger. Basically, what I need to do is find my angles. So I'm going to call this angle A. It's not angle A, but I'm just going to keep it since A is right here. So if I'm looking for this angle here, this is my opposite, and this is my adjacent. So using trig, I'm going to say tangent of angle A is 6 over 4, opposite over adjacent. So that angle A would be tangent inverse of 6 over 4, which gives you 56.3 degrees. So if this angle is 56.3, I know that this angle down here is also 56.3. So that means that the measure of angle A would have to be 112.6, which is also going to be the measure of angle C, because remember, our opposite angles in a rhombus are congruent. Then, if I know this is 56.3, this angle up here is going to be 33.7. So if this angle is 33.7, this angle is also 33.7. So that means that the measure of angle B is equal to 67.4 degrees, and the measure of angle D is equal to 67.4, because your opposite angles in a rhombus are congruent. Then we need to find our side length. So if you want to do Pythagorean theorem, you can, or if you would prefer to do trig, you can do it that way. So I'll do trig since I did Pythagorean theorem earlier in a case like this. So I'll use the 56.3, and this is my hypotenuse. So if I'm going to use sine, you could use cosine, that's up to you. The sine of 56.3 is going to be opposite over hypotenuse. So sine of 56.3 is 0.832, and so multiply by x, and then divide by 0.832. So 6 divided by 0.832 gives me a side length of 7.2. So the measures of the sides, AB, BC, CD, and DA are all going to be 7.2 because it is a rhombus. So all of them are the same. And it tells us they're in inches, so 7.2 inches. So hopefully that helps you with understanding how to use your trig ratios to solve for your different parts of your triangles.